Hey gang, it's Mr. Glure. I'm going to have a quick video here about multiplying and dividing fractions. So let's get into it. Multiplying fractions. Um, the idea about multiplying is you're usually going to make the number bigger, right? But again, we're working with fractions. So these aren't whole numbers usually, which means our numbers are usually going to get smaller. So I'm going to start out with a little visualization. I think this, well, it helps me anyway, understand a little bit better. So let's do a real easy example. Let's say we were doing 1/3 times 1/4. Okay, so let's try to draw this. We're going to start with the 1/3. We'll break this up into threes. As you see, there's 3 columns, right? And we are one of those. So we're going to shade that in. I'll just do a quick shade here. That's going to represent 1/3. Now multiplying means you're saying you want 1/3 of 1/4, right? We can use those words interchangeably. So we'll split this into fours horizontally. That'll represent our second fraction. So with this one, I'll shade it in. I'll just use lines or stripes. Okay, but we have 1/4. So shade in one out of those four. Okay. I'll represent this here. This is one of a total of 3. And this is one of a total of 4. Alright? So this is what we're actually asking when we say, can you multiply 1/3 of a 4th? Or you could say 1/4 of a 1/3. It's the same thing. So as you can see, the red part represents 1/3. But we only want 1/4 of that. So we broke it up into 4 pieces. And you can see the one box that is shaded both blue and red right here, right? There's only one. But how many boxes do we have total if we did this? We have 3, 6, 9, 12. 12 boxes total. So there is one box shaded out of 12 total. That is basically what we are asking you when we're asking you to multiply fractions. If you notice, I got a much smaller number, okay? Because we only want 1/4 of that 1/3. Okay, so that's the theory behind it. Now let's show you how to do this step by step. These steps are pretty straightforward, I think. I think this is easier than adding and subtracting. The first one is to change all mixed fractions to improper. Now, you usually do that anyway. It's just easier to work with, right? So let's try another example here. How about 3/4 times 2/5? All right, so the first one, it's already improper or proper fractions. Okay, so the next step is we're going to multiply the numerator by the numerator. That's pretty easy. 3 times 2 is going to be 6. And then you multiply the denominator by the denominator. 4 times 5 is going to be 20. And there's your answer so far. Got 1, 2, 3 steps done. The last one, you're going to do this for everything you do with fractions. You're going to change it back to a mixed fraction. You're going to reduce it as low as you can. And that's just to give a nice, neat answer. So we'll keep going. We'll try to make this neat. Always put a little equal sign there so we can see your steps. Now I know that 2 is going to go into both of them. So 2 is going to go into 6 3 times. And 20 is going to go in there 10 times. And there's nothing that's going to go evenly into 3 and 10. So that is where we're going to finish. Okay. Oh, and the great part about this is, unlike adding and subtracting, where you do need a common denominator, here you do not need a common denominator. So that saves you a step. It's a big step too. So that's pretty sweet. I think it's going to be much quicker. Let's do another quick one, just to make sure we know what we're doing here. I'll try a little bit of a harder one so we can get that first step in there. Let's say 2.5 times 6 and 1/3. Now these are whole numbers, so this one is going to get bigger, not smaller. But first step, let's see what we got here. Change all mixed fractions to improper. All right, easy peasy. So 2 times 2 plus 1 would be 5. And the denominator stays the same. Equal signs there. Okay. 3 times 6, 6, 12, 18. Plus 1 is 19. And our denominator stays the same. All right, first step done. What's next? Multiply the numerator by the numerator. So let's see here. A quick way to do this. I know I'm really good with tens, because you just add a 0. So let's just take that first 10 times 5, that would be 50. Then we're left with 9 times 5. 9 is just 1 less than 10. So take that 50 minus 5, that's 45. So if we did both of those, we have 50 and 45, that would make 95. That's just what I do in my head. I mean, there's other ways to do it. And 2 times 3 is 6. Okay, so there's numerators and denominators. But last thing we want is to change it to mixed fractions and reduce as low as we can go. So 90, that's a nice round number. I know that's going to be 15 times. And there's going to be 5 left over. 5 over 6, there's nothing going into both of those, so that is our final answer. All right. Okay, let's move on. The next one I was going to talk about is dividing fraction. Now, this is very similar. These are opposite functions, so they kind of work the same in a way. But again, just to help you visualize what's going on here, this is the same as any other dividing question, except for using fractions. So I gave you this example in class. Let's say we're going to make a fraction here. Let's say we have 3 out of 4 right there, right? If we're going to write that, that would be 3 over 4. So we have 3 shaded in out of 4. We're going to divide that by, let's just say a quarter. Okay, because we have 1 out of 4. Okay, now you're going to do the same thing, theoretically, as the multiplication. You divide your numerators and denominators, right? 3 divided by 1 is 3. And 4 divided by 4 is 1. If we change that to a mixed fraction, that is 3. And you can see that, right? We have 1 here, and we have 1, 2, 3. So it's 3 divided by 1. That's all we're doing with fractions. And here's the thing. This is a very clean example. Our denominators divide into each other. Our numerators divide into each other. So it works really well for that. But very rarely are you going to get such good numbers to work with. This is a problem that we're going to face all the time. So let me give you an example. Any other example, really. Let's say it was... can I erase that? Sure can. Alright, let's say it was 3/4 divided by half. That's going to be a little harder. Because yes, the denominators could be divided. Oh, wait. Okay, never mind that one. Let's try a different one. Let's say we had 3/5 divided by 2/3. Now 5 cannot evenly be divided by 3. Okay, those aren't going to work. And 3 can't be divided by 2 evenly. You'll get decimals and it's going to get really messy and it's just going to be very hard to work with. So the method we came up with, remember this is kind of a balancing act. Whatever you do to one side, you try to do the other. There's ways to work with these numbers to keep them the same though, right? So what we could do, we take that 3/5 and we can use the opposite of a division. We can use multiplication. Those are opposites, right? So if we do the opposite of our second fraction, they will cancel out. And by getting the opposite, I just mean we're going to flip it. Instead of 2 over 3, we're going to have 3 over 2. Okay, and then you treat this the exact same as one of those multiplication questions. We're going to multiply our numerators, which would be 9, and multiply our denominators, which would be 10. And that's it. That's all you're going to get. If you notice, this ends up being larger than before. That's because we're dividing fractions. Anyway, let's walk through a couple. So here's your steps, like before. Write one thing here. So a reciprocal just means to flip the fraction. Okay, so let's get an example up here to work with. How about we try a half of, well, we have 3/4, so we're going to try to find out what a half of 3/4 is. Okay? So, first step, change your mixed fractions. We don't have any mixed fractions, so that's done. Now, step number 2, change the division sign to a multiplication sign. Easy. We can put our first fraction in there. And we'll put our equal signs just so we can show our steps. Now we're going to use a reciprocal of the second fraction. Now underline that, okay? Don't make that mistake. You're not going to flip them both. You just want to flip the second one. Again, when you flip that, that cancels out changing the division to a multiplication. So it works out to be the same thing. Now we're just going to multiply the numerators and denominators, step 3. So 2 times 3 is 6. 4 times 1 is 4. Alright. The last one. Like always, we're going to change to mixed fractions. So we're going to reduce your answer. So 4 goes into 6 one time. We have 2 left over. And the denominator stays the same, but we can make that smaller. We can make that 1 and a half. There's your final answer. Alright. Let's try another one. A little bit tougher. Try it with mixed fractions this time. Here's a good example. How about 3 2/3 divided by 2 1/2. Alright. So again, the first step, we're going to change the mixed fractions to improper. So 3 times 3 is 9, plus 2 is 11 over 3. And next one we have 2 times 2 is 4, plus 1 is 5 over 2. So there we go, it's done. Next, we're going to change the sign and we're going to flip the second one. So multiply, here's the reciprocal. Alright, and now this is just like any other multiplication question. Multiply our numerators, we have 22. Multiply our denominators, we have 15. Alright. Done, done. Next one, we're going to change to mixed. So 15 goes in there one time, I know that. 7 left over. And we're going to keep the 15 the same. That's not going to get any smaller, so that is your answer. Okay. Ooh, one more thing, just real quick. We go over this. Exponents. We touched on this today. This is very straightforward, I think. All you're going to do is times a number by itself. That's the whole idea. So if we have 2/3 to the power of 2, that doesn't mean we're timesing it by 2. That means we're timesing it by itself. So if we wrote that out, that would be 2/3 times 2/3. Okay? Same as before. Just multiply numerators, which is 4, denominators, which is 9, and that's it. And whatever that power is how many times you're going to do it. If we had 2/3 to the power of 3, we would just have 2/3 times 2/3 times 2/3. You just do that in steps. I already know it's 4/9 for the first one, right? That would be 4/9 right there. But then we have another one times 2/3. Okay, and that would be 8 over 27. All right. So you just times it, whatever the number is. And one more quick example. When it comes to using mixed fractions, like all of the other ones, what you're going to do is first change it into improper so it's easier to work with. So that's 2 plus 1 is 3 over 2. Okay, and that's to the power of 2. So I'm timesing it by itself. 3 over 2. We get 9 over 4. We change it back. That'll go in there twice. 1 left over. Boom. Alright, so there's multiplying, dividing, and exponents. I hope that made sense. And if you have any questions, please feel free to ask me. Good luck. Thank you for listening.